Hi, my name is Jenny. Our project was object detection with the MBot Ranger, and my partners were Margarita and Karan. And I'm recording this without them because our recording situation wasn't working for this demo. So we're going to start with our gazebo simulation, and here you're going to see the robot moving around, exploring this room, which represents the apartment that we tested the physical robot in, and it will use its camera to determine what the color of the objects are. Once it determines the color of the objects, it will ding, signifying that it found an object, and put that corresponding color onto our map. There you can see that the orange showed up, and then it dinged for red, and it showed up the red. We see a maroon dot, and that must be sensor noise, because, yeah. But there you can see that the orange and the red roughly represent where the cone and the red backpack are. And now we're going to see the robot continue to explore the room, looking for the other objects, such as the blue cylinder by the fridge and the box. And so this exploration is based off the improved backtracking tree exploration algorithm, which basically represents the exploration path as a tree. Each node has a safe distance around it, which is the path that the robot can take. We represent this by moving about 5 units, and every 5 units we check if that node's neighbors are safe. If it's safe, we continue to move, and where the backtracking comes in is if it's not safe, we need to determine our most valuable node, so which node prior to us has the most safe space around it that we can continue to use to explore. And so to do this, we go through the nodes we already have. We give it a score based on how many neighbors that are safe that it has and its distance away from us. The one with the best score will be chosen, and we will use A star, the shortest path, to get to that node. And this is the improved version, because in the previous versions of this algorithm, you would backtrack from every node you've gone to get to that most valuable node. And this kind of goes around that step for a quicker solution. And so some modifications from the algorithm we had to make was, instead of representing our safe space with polygons, we just represent it with the 8 neighbors that are around that node. This was just easier with the occupancy map representation we were using. And so, we'll just watch as the robot moves around and explores this area. And then after this video, we'll see another short gazebo simulation video, and then we'll move on to our physical robot videos. And here I just move the camera around so that you can see the orientation that the map comes out in, and our visualization is basically like upside down from the way we actually start, because as you can see where the orange and red dots are, and then the black representing the box that we found, and now this area here that we're in, that we're putting hits in. And so now we're moving on to our second example, where we'll just see some more mapping. There you go, the orange dot comes up. We'll have a ding probably for the red backpack. There you go. And I just want to point out that when something is dinged, it won't ding for that object again. And this is just so that we avoid dinging for things that we don't need to ding for. Basically, if there was multiple red things, we only want to ding for the one that we want, not for all of the red things. And so in this example, we're going to see one of the complications we came to. Sometimes the robot won't have enough time to execute the given path, so it'll kind of just stop in one place, trying to orient itself in order to execute that path, but it'll change before it can.
This isn't a problem though, because eventually it will be given a path that it can execute.
and it won't be stuck in one place, and it will continue to explore. And here we can see that it's able to execute this path, so now it's moving on. Now we're going to move on to our physical robot videos. So here we can see we start our control program on the laptop. The robot's connected with a wire. We start the robot, and now the robot is moving around. And once it sees this green object, it's going to light up green, alert us that it's there, and we'll see the map visualization for this once the robot is done running. And so now it's going to encounter the red, lights up red, avoided all the objects that it was seeing, which is good. And now here we have a map which represents the area the robot was moving around. Now we're going to see the robot moving around a larger area of the apartment, not connected to the computer, so we won't be seeing a map output here, but this is just kind of to show the object detection and the robot moving around, having obstacle avoidance. And here we can see him moving around. The green object's over there, so hopefully when it gets near there, he'll be able to light up green. Give us a noise, let us know. And so I'll just let this play out longer. Now we're going to see an object detection demo with the Pixy Cam. We just thought this was an interesting component to add to show what's going on behind the scenes with the camera on the physical robot. These are the objects we trained it to detect, and you can see once it sees the object, it labels it. And this is part of the information we used when creating the map and having the robot light up the color of the object. Now finally, we'll just see a simple detection in Gazebo again, where it's going to drive towards this red backpack, and then we'll see that it puts a red dot and dings. And there we go. So, those are our demo videos. Thank you for watching.